All good to go? With no further ado, Tina from Dashlane, please make her feel welcome.
Hi, everyone. So excited to be here this morning after your mimosas. Well, 4 cups of coffee on my side. But I'm Tina Zhuo, lead product manager at Dashlane, where I work on a team focused on web analysis with machine learning and the contextual experience of our users. So that includes passkey registration, authentication, and also just helping to keep our users safe wherever they might go with us along the web. So today we're going to talk about how we leveled up phishing resistance for our users beyond initial passkey implementation, including making use of cool technologies like the buzzwords, which may be mysterious in the title, understanding customer fears and behaviors, and fighting fire with smarter fire. So I hope you'll come away with even more to add to our conversation in the community on combating phishing resistance, both in your own organizations and here. Green button. So Dashlane, you might know us as a password manager or a credential manager, but our mission is credential security. And so that means we're trying to make online access effortless and secure for our users. As part of this mission, we have been supporting passkeys as a passkey provider since 2022 and making it easy to manage and sign in with passkeys for our users' different relying parties and services. So with passkey support came the promise of phishing resistance. FIDO Alliance put it well. With passkeys, there are no passwords to steal and no sign-in data that can be used to perpetuate attacks. So it was a no-brainer for us before, as only a password manager. Any services that our users logged into with passwords, even complex and unique ones, carried risks of phishing. So we started offering passkey support, and they no longer had anything to worry about. Our job was done, and I retired. So that's obviously not true. We're a credential security provider. So even with passkeys available and supported, our job wasn't done. Our users still faced risks online, with enemies remaining dangers throughout the online realm, and even directly, actually, in their usage of passkeys managed by Dashlane. So who are these enemies? They may be many, but we'll focus on just 2 today: private key exposure and lingering phishing risk. So you all, my fellow adventurers, and I will go on a quest today to fight these 2 threats that are still standing between users and the promise of phishing resistance. And we'll talk about some lessons and practical tips along the way. That's us, the adventurer party. So let's go. Our first enemy is actually a passkey security hole. Private key exposure, or when the passkey private key is, well, exposed and vulnerable. So to explain a bit more, most third-party password managers like Dashlane have browser extensions. And when you use one to store and log in with passkeys, here's what's happening. You create and save the passkey locally on your device. Then the credential manager encrypts and stores the private key. And later when you log in, that private key is decrypted on your device in the memory of the browser extension so that you can authenticate, finish the login. So there's a small window of time here where the private key is decrypted in device memory. And there's an issue here. If your device is compromised, the private key can be stolen, your passkey used, your account taken over. I'm going to be honest with you that that's not a big problem. We're talking device compromise, which most credential managers don't even include in their security models. Once you reach that point, it might be game over in terms of security. A bigger problem that concerned us with private key exposure was around credential sharing. So if you aren't familiar with credential sharing, maybe once upon a time you've shared a Netflix password. But let's walk through a business use case. Let's say that your organization has some social media accounts for the brand, and you need several different people to be able to access them. But you want to make sure that the accounts themselves remain secure with complex, unique passwords, not company name 2025 for every single one. So once you have these complex, unique passwords, how do you make sure that the right people have access? You can, and some people do, Slack or email the plain text passwords. You look guilty, it's okay. Very good. Even worse might be keeping a spreadsheet with every single account username and password in plain text and giving that access to everyone who needs it. So a better solution here, and actually a reason why many of our customers purchase Dashlane, is secure credential sharing. A credential manager will use cryptography to securely distribute the credentials to each sharing recipient. And so how do credential managers share passkeys? I'm sad to tell you that credential managers, and not only third-party credential managers using browser extensions, share passkeys the same way. They take the passkey, including the value of the private key, and distribute it directly to sharing recipients. So that has some downsides, because you're sharing a passkey, and when you give control of the private key value, that's complete control of the passkey itself. So in an organizational setting, for example, you can't know that the people who you share your passkey to are going to keep your passkey secrets inside the organization and not leaking out. Maybe that's fine for passwords, we don't have a choice. But given the fabric of passkeys and how they work, and the technology that's available to us as an industry today, it didn't have to be this way. So how can we make it better? And our answer was to harness the magic, or really cool technology, of confidential computing. For a quick explanation, data is usually encrypted at rest and in transit, it's no big deal. But it usually has to be decrypted locally when it's being used or processed. So in our example, when logging in, decrypting the passkey private key to sign the challenge and complete login on the user's device, or on the device of any sharing recipient. So confidential computing provides a solution to having to decrypt data for processing by making it possible to process data while keeping it private and protected at all times. And it does this by using cloud-based secure enclaves, basically black boxes that ensure privacy and confidentiality while performing sensitive operations. And it makes sure that no one can see what's happening inside, not even those who implemented a solution, like in our case, Dashlane employees. So how did we use confidential computing to secure passkeys? By making everything happen in a secure cloud enclave. So what used to take place locally on the user's device, creating the passkey and decrypting the key to sign the challenge, that's now all happening in a secure cloud enclave, meaning that the private key is actually private and protected at all times. So what are the implications for passkey sharing? It makes it possible to share passkeys in a more secure and controlled way, sharing by reference instead of by value, meaning that you're sharing access to the private key to the secure cloud enclave where the passkey can sign the challenge and complete login without ever having to share the value of the private key itself. And then when you're sharing, it's finally only the encryption keys that are given to sharing recipients. So we updated our passkey implementation so that the private key doesn't have to leave the secure enclave. And you might ask, why didn't we do that from the start? So the answer here is confidential computing isn't that easy. It's in a black box. Development in a black box is not that easy. When we first considered passkey support, we wanted our users to be able to benefit from phishing-resistant login wherever they could as soon as possible. And confidential computing added enough complexity that we had to justify the added value for our users. So we saved that for a later iteration, and that's where the sharing use case was really valuable. Because instead of framing the value primarily as risk reduction, we used it to tell the story of a better future, one enabling more secure and controlled passkey sharing, especially for some secure business use cases. And with that business case in hand, we built and rolled out the change. A key requirement that we had was lack of friction. We already had a seamless passkey experience, and we wanted to make sure that an iteration bringing added security did not do so at the cost of the user experience, because if there is friction, users will find a way to take the easy route at the expense of security. That's just human nature. Smart defaults prevail. So we did a gradual rollout. We beta tested first by letting our tech enthusiast beta users opt in to these better passkeys on web. We monitored feedback and performance, and then we rolled out the enclave secured passkeys as the only option to all of our users on web, iOS, and Android. And then, good news. Our passkey usage, performance, success, they all remain steady, except that passkey adoption is always growing bit by bit, thanks to all of you. Hardly any customers noticed either, but in our case, again, that was a good thing. We wanted to make sure that quietly moving everyone to enclave secured passkeys wouldn't bring any slowdown or impact to usability. It was just better security behind the scenes. And then some of our tech enthusiast users were really interested in the improved privacy and control over passkeys. It's really 99.99% we have to clean up a feature flip. Yeah. So that's one threat down, and we can move on to the second one, lingering phishing risk. So to explain it more, we do have passkeys that are phishing resistant by design, even very secure, never exposing the private key. But we still have phishing risk, of course. It might not apply to many people at Authenticate, but not all services have implemented passkeys yet. And then, of course, even if you've implemented passkeys, the services might keep passwords lying around in their systems, whether as a fallback method or even as the primary authentication method, while passkeys remain an advanced option hidden away somewhere in the back. Then another problem is that other data still remains phishable. Payment data, personal data, not yet replaced by passkeys. So looking at this hydra of phishing risk is just to say that even if we've tried to chop off a head by offering phishing-resistant passkeys as a method, phishing risk isn't dead. Maybe we have more and more risk growing back more dangerously than before, especially with AI-augmented phishing tactics. So taking us to this part of our quest, as guardians of our customers' credentials, how can we better keep them safe across the online realm, no matter the state of password lists for a given service that our users are logging into? Because the goal isn't shipping passkey support, but phishing resistance. You might say, wait, if your customers are so security conscious, don't they already have phishing solutions in place? Yes. Email filtering, block lists of known phishing sites, and security awareness training are 3 tactics commonly deployed against phishing. But they do have gaps, and attackers have leveled up. There was a great talk by Yuri this week explaining how phishing campaigns can now be spun up more quickly and cheaply than ever before, and crafted to look more convincing than before, and increasingly bypassing traditional protections. If you get a phishing link through a compromised LinkedIn account or WhatsApp message, your email filter cannot help you. And a block list isn't much help in the case of a 0-day phishing attack. If you visit a site before it has the time to be added to a block list and updated on your site. I think the jury's out on security awareness training. It's a good practice. I'm just going to tell you that some of our customers have expressed they don't believe it to be effective. I personally disagree, and I've been well trained to never, ever check my email. But in seriousness, security awareness training does encourage and depend on constant vigilance, and it only takes one moment for you to be caught unawares and a phishing attack to take hold. So we looked at this landscape and listened to our customers' concerns about existing phishing risk, and we found an opportunity to address a specific weakness, an unmet phishing risk gap for the last mile in the browser on spoof websites, where we could bring added protection. So you might ask what we've all been asking ourselves. Also, it's in the talk title. If attackers are using AI, why don't we also use AI to shore up our phishing defenses and fight back? It's a fair point. At Dashlane, though, we do have some constraints that affect our ability to use AI. They may or may not apply to you as well. For one, we are a zero-knowledge platform, so we couldn't take the route of scanning user data that we don't have in the cloud. And if we did, we would lose the trust of all of our customers because we manage their confidential credentials. Another point is that we are a browser extension, so this places a strict constraint on the size limit of our build. We also have a need for fast performance as we're going where our customers are going along the web, helping them log in. We need to be fast and detect and alert them to risk in real time. So this rules out heavyweight solutions for us, like embedding a large language model for now. So we did fight back with AI, but we just trained our own lightweight machine learning model to detect phishing risk in real time as soon as we land on a spoof page. So this worked within our constraints. The lightweight model was small enough to be shipped in our browser extension, and the inference was fast enough to be useful. A really important part for us here is that that inference is happening client-side on user devices, so that we can analyze and warn about phishing risk. They have the model locally, and we don't ever have to know what they're doing online or where they're going. We're sending this data to a large language model. So this worked within our zero-knowledge architecture, as well as our users' privacy expectations. And it adds a new layer of defense to complement traditional phishing solutions. One more click, sorry. There we go. So I apologize, and with great thanks to the IT team back there, this video is not working because I use Google Slides, but if you would like to meet me after, I'll happily live demo for you. We had a user on Reddit post about a new phishing website posing as a Dashlane redirect, which does not exist. And our phishing detection model caught it as soon as we checked it out. So I'm going to show you a simulation that we made on the Google slide. So it's much faster than what I just clicked. The detection will happen in 10 to 20 milliseconds as soon as you land on a site. And that means that you're protected no matter how you got there, like even if you clicked a link in a DM. The generalizable detection with AI also means that you don't have to hope that there was enough time for the site to be added to a block list beforehand. It worked the first time we visited and learned of the site. And then as to how it complements security awareness training, take a look at the alert. We throw up a warning very quickly. We explain the risk. We call out the current URL. And what we're also doing here is blocking interaction with the background page for protection while keeping it visible so that finally it's the human user who can look at the website, the URL, and use their judgment, call on their security awareness training to make the final call. So that all is great as long as the model is actually offering accurate detection. So how do we achieve that? Well, we have an experienced machine learning team, and we used abundant high-quality training data. This is not our first AI rodeo. We've had an AI-powered autofill in production for 5 years, trained on a massive set of legitimate web page data. And then we also had tools in place to collect and label the data and feed it to the model. So it was actually pretty economical for us. Here, we're working to detect phishing websites. So what we did is repurposed our data set of legitimate web pages, and we extended our tools and processes to collect new phishing page data. And then we trained a new model through feature engineering and training on the legitimate and phishing websites. In a few iterations, we arrived at a model that was capable of detecting patterns highly correlated with phishing risk. So whenever you land on a site, the model's analyzing 80 different web page characteristics to provide a phishing risk score. This is just a visual showing some example, but it'll include link attributes, iframe attributes, tags, scripts, more. Sorry, I clicked the wrong button. So in some stats, our model had a 97% F1 score, which we use machine learning as a proxy rate for accuracy when detecting phishing versus legitimate websites. And then we had a false positive rate of 0.02%. A false positive for us is when the model thinks that a legitimate website is phishing. 0.02% seems low, maybe, but it does mean that out of 100,000 real websites, there are going to be 200 mistakenly flagged as phishing. And so we launched the AI anti-phishing in early access a few months ago, and we have had some reports of these false positives happening on internal company websites, which don't have to be optimized for growth or follow any kind of recognizable web convention because employees are forced to use them. And because they are maybe strangely coded, they were more likely to trigger the model. The problem here is if people see phishing alerts on websites that they use and trust daily, it does create a boy who cried wolf situation. And what we really didn't want was to train our users into automatically closing and clicking out of the alerts. So we came back with an allow list feature, so admins could manage false positives themselves. So this gave them control if they see in their insights that there's some alerts on an internal site or otherwise a safe website, the admin can hide the alert for their whole team at once and preserve the alert impact for when it matters. So there's more in a very funny human twist in some usability testing. Some employee users saw the phishing alerts and thought that the alerts themselves were trying to phish them. Security awareness training does work, right? So to make sure that the alerts were trusted, we added this in-product guidance for admins. Whenever you go turn on the alerts or make some change to them, we prompt you with this information to inform your teams that you're rolling out this change, what they look like, and how to respond. The whole message and the image are copyable. And so this way, the users aren't caught off guard, and the alerts will have the intended effect. So in the end, this lightweight model and proactive alerting gave our users some real-time phishing protection and giving added coverage in cases that weren't well addressed by traditional solutions like email filtering and block lists alone, and just giving a timely assist for security awareness training to kick in, and extending our customers' overall defense to cover the password backdoors and sensitive data that can still get phished, all while we continue our journey towards passwordless and getting rid of this phishable data with phishing-resistant alternatives. So in terms of customer interest, the AI anti-phishing early access program has been the most popular one in Dashlane's history, with 3 times the interest of our next most popular program. And we are looking forward to launching imminently and extending this coverage to more of our customers. Taking us to the end of our quest. So we've mitigated 2 key cyber threats, private key exposure and lingering phishing risk. And how we solve them? With confidential computing to keep private keys private at all times, even during processing, with secure enclaves, and a business case that focused on new added value rather than just risk reduction. And a deployment that started with the beta opt-in, but then ended up rolling out to everyone as the only option, and with no impact to passkey usage or performance. And then to protect against lingering phishing risk, whether passwords or phishable data not yet replaced with passkeys, we added the AI-powered alerts for generalizable, privacy-preserving, and real-time phishing detection, and workarounds for the false positives that you get in any machine learning solution. And so here, taking it to our finish, we've improved our passkey management and added a new layer of phishing defense, but we are one passkey provider. And this is only one battle of our greater ongoing fight against phishing. So many of you here at Authenticate, as relying parties, are already doing your part by implementing passkeys. And that's a big step against phishing. And every new deployment makes the ecosystem stronger. But as we've seen, there's more to be done. So as long as password backdoors remain, users are still exposed to phishing risk. And it's not only on relying parties to implement passkeys and go passwordless, it's also on passkey providers to strengthen how we manage our passkeys, and also considering the huge target on our backs for cyber attackers to improve defense in all of our products as well as internally. And it's on all of us as an industry, relying parties, passkey providers, and other identity security providers to find opportunities to strengthen defenses and build new ones against the phishing threats still sticking around. And then the last point here, making sure that our solutions are user-friendly. Usability is security. So here are some practical tips to execute against those actions. As we know that users take the route of least resistance, make the route of least resistance the secure one. Make the secure option the default. And also, don't rely on opt-in and reduce cognitive load where you can, so it becomes an easy decision to, for example, go passwordless or keep some added protections enabled. When you're rolling out these new protections, when no single tool gives complete protection, so layer your defenses, whether internally or by getting creative to add new ones in your product. When you're rolling out new protections, make sure that your users, internal or external, know to trust them, like notifying when you're about to make a change, what that experience looks like. Make it really easy for your customers to do that. And then finally, and why my job never gets old after a decade of product management, users will always surprise you. And so no surprises to anyone with this tip. We keep listening and learning and iterating. So thank you very much for your time today, and looking forward to continuing the conversation and improving phishing resistance across the landscape together. Thanks very much.
Thank you, Tina. That was very interesting and certainly filled in some gaps in my own knowledge there. I do have a question online, and I'm going to combine actually this question with one of my own. And it's about the first part of your topic, the confidential computing and your cloud-based secure enclave, if you want to call it that. So the question is asked here is will the secure enclave work with synced passkeys as well, and how, right? And I want to add one thing to that, which is, does the use of this cloud-based confidential computing black box require now that Dashlane has to run in an internet-connected environment all the time and not, in an intranet that may only be occasionally connected?
Great questions. So if you are using like a first-party solution that can access the device-based secure enclaves, that's one. And our solution as a provider of synced passkeys that do support easy cross-platform usage, ours are cloud-based secure enclaves. And so if you are using Dashlane or any other solution that uses such a technique, not yet, you have no fear about that ability to access. And that's a really great question. One trade-off that we did make here was taking off our offline passkey support because we do rely on a cloud provider of our confidential computing framework.
That pretty much covers it, folks, and we're right on time here. So please thank Tina again for her presentation. I thought it was great. And if you've got some time, open the app, fill in the survey. Our next session will start in 10 minutes. Thanks, Tina.
Thanks very much. And I'll live demo in the corner if anyone wants.